A basic introduction to propositional logic. Demonstration 6.2-out. The negation is symbolized by the dash or tilde sign, which is preferred, just so it doesn't get confused with other dash symbols that we use, like for example on the turnstile. It means not, and it is a negation. The dash out rule, or negation out, begins with a negated term and shows that its opposite, meaning the affirming version, must be true since it will lead to a contradiction. Problem 92. If I don't stay single, I'll have to give up all my hobbies. But I love my hobbies. Maybe I can keep my hobbies while being married? But I don't think that's possible, so I guess I'll stay single. Step 1, find the code words. For negations, remember, you start with the affirming version, or the positive version, and negate that. Now, in the case of marriage and being single, it can be a little tricky because which one is the default? It's not clear, right? But in this case, since single is capitalized for you, we'll use that as the standard base. And if you negate that to say not single, that will equal married. Okay, so you have two code words here. Single, having hobbies will be with capital H. Step 2, symbolize the relationships in the argument. Okay, so now read through and code each of the lines. The first statement says, if I don't stay single, I'll have to give up all my hobbies. So if not S, okay, arrow, not H. There's an if then, and it has negated terms, right? But I love my hobbies. So this implies H, right? I want my hobbies. I want to keep doing my hobbies. Okay, the third statement is not a proposition. So it's just a question, right? Maybe I can keep my hobbies while being married. So this is irrelevant to the argument. But I don't think it's possible. This next statement says, well, I don't think it's possible. So we have, it is not possible, not H and not S. And you're negating the entire thing because you're saying, look, I don't think this entire thing's possible. What is not possible? To have hobbies while being married, right? So go back to the previous statement with the question. It was saying keeping your hobbies, that would be H, and being married. In this case, since we already said S is single, then not S will be married, right? So H and not S, I don't think that's possible, and you put a dash in front of the entire thing. So use a grouper, since the negation is the entire thing. It's not possible for both of these to happen together, and then married equals not single. Although this is a statement, it will end up being superfluous to the actual proof, but it is here stated. The fifth statement is S, which is the conclusion, right? So I guess I'll stay single. Okay, taking all of those pieces, put them into your sequence. Not S, arrow, not H, H, not H and not S, and then S. The premises, of course, are separated by commas. The conclusion is after the turnstile. Next, set up the proof. You have to put your assumptions at the top, your conclusion at the bottom. In this case, we have 3 assumptions. Not S will lead to not H. Then we have H. On line 3, we have not H and not S. And then we need to somehow get to S. Scanning the assumptions you already have, how are you going to get to S? We don't have S anywhere in those assumptions. In fact, we have not S. And then also they're trapped, right, with arrows and ands and parentheses. So it's not like you just have S anywhere. So next we solve the proof. Since you need to conclude with an S, it might work to just start with the opposite, right? Not S. And not only is it a good indication because you have just a capital letter there to use the opposite of it, but because you do have dashes. So usually you're like, oh, I can get the dash from here and show a contradiction. So introduce not S as a PA, temporary or provisional assumption, and try to show a contradiction. So if you put not S on line 4 as the PA, what do you think could be a suitable contradiction? Well, probably it's going to be the other letter, right? You see H and you see not H, right? So that's a good target. So put that on line 6. Put that right before you show S, right? You have to get to a contradiction. So you know you need H and not H on line 6. Well, that's a conjunction, right? You need H, you need not H. Well, you have H on line 2, so you know you need to also get not H. So put that on line 5. And so you filled in, again, working backwards, reverse engineering, how you're going to get to that conclusion. Now let's look at the justification column. Line 4 was just the PA. Line 5 used 1 and 4 arrow out, okay? Line 1 says if you have not S, you'll get not H. And we do have not S on line 4, and so we get the not H. We're left with the consequent, right, using arrow out. All right, well, now we have our not H. We have line 2, H, and line 5, not H. We combine those using and in, right? We've created a conjunction or an and. And then on line 7, we show how many lines did it take us to get to that contradiction, right? We started with not S on line 4, and we got to the contradiction H and not H by line 6. So lines 4 through 6 dash out because we've removed the dash, right? We started with not S, so therefore, because it's a contradiction, we're left with just S. Now, don't forget, once you introduce a PA, provisional assumption, you have to keep track of all the assumptions, right? Use the AD column at the front, at the beginning of the first column of this proof. So remember, assumptions just depend on themselves. The assumptions in this proof are lines 1, 2, 3. Those are original assumptions. And line 4 also is an assumption. It's a provisional one, right? So those just depend on themselves, 1, 2, 3, and 4. Line 5, look at the justification, right? 1 and 4 arrow out. Well, 1 and 4 are assumptions, so just put those there, 1, 4. Line 6, that's 2 and 5. Well, what about 2 and 5? We've already calculated them, so just start checking the AD column. Okay, line 2 is 2, line 5 is 1 and 4, so just put 1, 2, and 4. Okay, and then line 7, that's 4 through 6. Let's check what we've already calculated. 4 through 6 has 1, 2, and 4, right? None of them have really touched line 3. That assumption, it's kind of irrelevant. And then 1, 2, and 4 should be there. However, just like arrow in, dash out also removes PA, right? It removes the provisional assumption it depended on. And so therefore, and again, for a deeper understanding of why that is, look at the textbook. But just know that dash out also removes the PA, so we take out the dependence on assumption 4. And we're just left with 1 and 2 for the final line, for the final conclusion. And those are just original assumptions. Here's the final answer of the sequent and the proof.